Hello students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Community College. And I'm here with the design example 5, video number 3 or 4, where we are doing data processing using nested loop. We are reading data from one input file and we are writing data to an output file as well as to console. Writing to console is little trivial. That's not such an important thing, but writing to file is the key thing. So in this video, we'll develop the algorithm and we're going to do it in several steps. First of all, I'm just going to review for you the table of Boolean conditions that I taught in the previous video. And it seems like an overkill. I think a lot of people need several iterations of the structure of the software. So I put in some colors on the previous tables. So I'm just going to go through them one more time, and then I'm going to do a high level algorithm which is short. That means it's showing you a macroscopic picture, and then from there we can see the microscopic picture, step-by-step details of the algorithm. More detailed your algorithm is, less time you will spend writing the source code and less frustration you'll have with compile errors and logical errors which gives wrong answers. So that's why we spend so much time on algorithms and perfect them and analysis that by the time it comes to coding in the compiler, it becomes almost trivial. That's our goal here. Okay, so I'm going to go and do the Boolean conditions again. So goal was we find out what are the highest level selections and what is or are the algorithm tasks embedded inside it, and those tasks may be more selections and repetitions. And we keep layering selections and repetitions as needed until we have constructed the structure of whole software. So obviously you can't read a file unless you open it. So in is the software called ifstream object, is the variable of that type. Isopen is the function embedded inside that object. Whole purpose of in.isopen means that this function called with this object returns true if file indeed exists. Okay? If it returns false, then file does not exist, or we can't actually connect to the file. In that case, solution is very simple. We'll print fail to open file. So you'll see that this will become one block in our software structure. This will be outermost else block, and this will be our first if block. Entire software will be embedded inside this. So if this is true, then we will ask user to give us the path of the output file, and if output file is opened successfully, then we are in business. Then we can start reading this input file. Okay, so then we do these selections. We check the validity of the output file. If that is open function will return true. In that case, we'll do this yellow box. Okay, so embedded inside this if structure will be this yellow box. But if output file is failed to open or create, then this will be our block before this else block, where we'll print fail to open or create output file. Okay, but if we can create output file successfully, then this yellow block is the one that will execute. In that case, we'll check that this condition is true, in.peak not UF. That would mean that file has some data. By the time we get to here, if this condition is false, which I should have put it down here, we would have said, actually this is not if statement, so this loop will not enter at all if file is empty. But if file has some data, it will enter. So this true means that file has certain data, and we do the UF while loop. This is the outer loop. This is done so we can compute number of students in that file to which in is attached, and then there's a whole bunch of stuff to be done. For that we go to table 2. So you can think of that we took the table 2, which is coming in a second, and just embedded right here. So look at the layers. Testing, this was one layer, then we're testing this, that's the second layer. So inside this layer is this green box, and inside this testing condition layer is this yellow box. So this layering is extremely important, and this is a technology that I have invented and perfected, but this is extremely important to learn how to do these layerings of software. If this is true, we have this layer, green. If this is true, we have this layer called yellow. So it's like those Russian dolls, doll within a doll within a doll. That's how you understand the structure of the software. And also think that table 2 that we're going to look at in a second is actually embedded right here. It's very hard to do huge number of these in a small real estate that we have here. So we have to take expand the data to other table. So let's see what we go under the table in table 2, which is under scope of this Boolean condition being true. Okay, and that's being tested every time outer loop repeats. When UF is read, then the loop will exit. I've given a huge description of that in video number 3, I believe. Yeah, so you should watch that again if you didn't understand this. Okay, so this will be done when this is true. So let's say table 2. So table 2 again, first thing we're going to do is, after doing num student equal to num student plus 1, we'll read the first score from the file. By now you know the structure of the file very clearly. So that is one another layering. So in this layer we'll test this condition. If that is true, that means the student had one or more test scores. So we'll use the sentinel while loop, and then this whole layer is embedded inside this loop. So we continue reading and processing student test data until sentinel value is read, and we'll say sum equal to sum plus 1 score, num test equal to num test plus 1. Purpose of that is to sum of all the scores, test scores. Purpose of that is to count the scores. And by now you know there will be a sentinel value for the students who took one or more tests. When that is read, this condition will become false, and that is this condition here, and then we'll exit the loop. Okay. So still this is under UF not equal to 0 under this layer, table 2. So that's one of the thing under that layer, that the sentinel loop. After that, in sequence, that if number of tests that were being counted here are greater than 0, that means a student has taken one or more tests. If that is true, then we use expression 1 to compute mean, see page 6 or earlier, and then rounded mean, again see the page 6. So under this condition we have this whole layer embedded in the green. But inside the green then we have additional layers, and here that we have 1, 2, 3, 4, 5 layers. They are not embedded between each other. They are like nested if and else. So each one is layer of itself. So if rounded mean is greater than 0, then we use if grade is A, greater than or equal to 80, grade is B. We use else if there. Greater than or equal to 70, else if, grade is C. And greater than or equal to 60, grade is D. And last one does not have to be else if, it could be just else, and grade is F. So that's the structure we have set up. So based on this structure, now we go to our algorithm writing. This is something we want to describe in high level, so that again, translating from the table into the words, we kind of understand structure in words now. So it will be we'll open input file and validate file opening. Once that is done, we'll open output file and validate the output file opening. Then we'll do our loop while not end of file, and you saw that in earlier in the table. That was in, so this is the whole thing is embedded under this, and under this is embedded 3 and 3.1 and so on. We'll increment number of students by 1. We'll read the student's first and last name. We'll output to console and output file the student name. We'll read the very first score. And don't forget, the data in the file is like this. First name, last name, number of scores, could be 4, could be 5, could be 1, and a central value. And there might be people who have taken no test, first name, last name, and only a central value. So remember this structure. You can't afford to forget that one. Okay, so so that's the one we are doing here. If they have taken one or more tests and test scores is 0 or higher than 0, then this loop will keep going on until the next score is read, or finally the central value will be read. That's a negative score. Negative greater than 0 will be false, and you'll exit the loop. And then if they took one or more tests, then this will be true, and that means we can compute a grade. We find the mean, which is sum divided by num test, cast to double so that we get the real value, and then rounded mean. We have explained this rounding procedure many times. And then we can print to console and file the sum, num test, mean, and rounded mean. And then we'll use nested if and else to get the grades A, B, C, D. Those were described in these layers, this one, and again we'll show you the algorithm as well. Okay, so then we'll print to console and file the grade of the student. Otherwise, if if this condition is false, that means they did not take a test, and then we'll print you did not take any test. Okay, so this was the high level. Now let's see, and then of course end of the OF loop, and then we'll print to console number of students and a whole bunch of things. So that's the high levels. Let's go down to the low level. Flowchart I described in the last video. It's really mostly does the central loop and the grading. So you can look at that in the document. And this is the detailed algorithm. And if you understand detailed algorithm, then everything is going to be very easy. We depend on the layering of the Boolean condition to understand key parts of it. Other parts are not that hard. Okay, so you cannot get input file unless you prompt for the full path. Okay, and path could be space separated. You need to store that into a string, and in C++ you'll use getLine. And then bind this file name with the stream object, and then you have to do the file opening validation. It's absolutely essential that every time you open a file, that means you attach ifstream or offstream object to the file name that user has provided, that you do this validation in dot open, etc. Okay? If you don't do that, you don't know. A wrong path may have been provided, and your program will just hang. It is absolutely not acceptable not to do the file opening validation. That's always done. Okay, so here I've changed it a little bit compared to the Boolean condition I showed you before. Here I'm testing not in is open. That means if this returns false, negation will make it true. Then we just say failed to open file. Else means that a true will be returned here and negation will be false. So that won't execute, it will fall to else block. I've done it opposite in the uh, table I showed earlier, but it means the same thing. So if my input file is open, then I prompt them to give me the path to the output file, full path. I store that into a string, and I declare an offstream object, and I call the open function to make a connection between this string and this output file. Output file may exist or may not. If it doesn't exist, it will create it. If it exists and its writing to file is not done in append mode, then all the data will be overwritten by the new data. Again, as I mentioned before, file opening validation always has to be done. And here, again, I'm doing opposite of what I did in the table. We call out is open function. Function call is always made with parentheses. If this returns false, that means output file could not be opened to writing. Negation of false is true, and then we say fail to open output file. But if this return true, negation of that will be false. That means if task will not be executed, else will be executing. And then we apply whatever format in which we want to print the floating point data. Okay, so you have to pre-decide that. Here I'm just going to not decide. I'll decide when I go to the source code. And you can read that, but I'm going to focus on this. I want to count how many students are in the file, so I set num students to 0, and then these are set for other things. Read the document for that. So now I'm ready to go to my UF loop. So while end of file is not reached, and you can see the C++ syntax either up in the table of Boolean conditions or later on in the source code. So first thing I do is I increase number of students by 1, because if I entered the loop, UF loop, that means at least I have 1 student. Otherwise, it would have read the UF character, and this loop, pretest loop, would not even have been entered. Then if you remember the file structure, which was, of course, I will show you again. Doesn't hurt to show you as many times as I have to. Yeah. So don't forget this file structure. I may not be able to show you every time. First name, last name, scores. And video 7, again, I've done it in tremendous depth. I hope by now you understand it. So this is the file we're reading. We're getting to our algorithm. Okay. Obviously, we'll read the student first and last name, store in variables first and last name. These were done in the first video, what the variable names are. And we say hello to them. Hello, first name, last name, new line. And one is to console to file, console, other to file. I'm going to only focus print to file from now on. Now, this is the most important part in the code. You can set one score that reads the student score to a value or not. If you are concerned about the non-uniformity, you can set all of them to 0. But sum and num tests are considered accumulators. What does that mean? That means when I go inside the loop, I'm storing into sum of all the scores. That's why it acts as an accumulator. It accumulates sum of all the scores. And same thing with the num test. It's accumulating number of tests. I call them accumulators. The rule in software is that if you don't initialize accumulators, they have garbage value. And on a garbage value, you cannot perform sum like here or here. This is a very serious issue which is easily forgotten. Even if you declared your sum and num test here somewhere, that doesn't even matter. You can declare them anywhere you want. But accumulator always has to be initialized. Okay, so accumulators have to be initialized just before the loop in which they are used. They're used in this loop, so they have to be initialized. Okay, and I'm mentioning that again once here. Sum and num test act as accumulator. Their non-initialization will only allow first record to process correctly. Residual value in lack of initialization will corrupt corresponding data for subsequent record. And it would be garbage in and garbage out even for the first record actually. Okay, so if this condition is true, we are printing to the file the score we just read in the prime read here. That's our prime read. And then we do the sum, and then we increase the number of tests by 1. And this was described in tremendous depth by this when I described, okay, where are we? Sorry. Give me a second. When I described this picture here, okay, so just remember this picture with the algorithm that I'm just discussing right now. Seems like an overkill, but all right. So inside the loop, we print each score, we sum up each score, and we increase number of tests. So this allows us to sum up all the score and count how many tests they took. And then we do the update read. Once update read the sentinel value, minus 1 greater than or equal to 0 will be false, and we exit the loop. There has to be new line character printed because we are printing scores here. We couldn't do new line here because then scores will show up in different lines. So we just do it after the loop has ended. Now this num test having value greater than 0 means that the student took one or more tests. But let's take the case when you saw a case of Miss Genius where she didn't take any tests. So the first value read here, prime read, was a negative value. Negative value greater than 0 is false. So loop will not be entered. Sum and num test will both be 0. And if num test is 0, then this condition will be false. So I just go to my else block. I'll show you that first. Else block that you did not take any test. That's what we print for them. But if a student took one or more tests, we do have for them the sum and the number of tests taken. Okay, so this avoids division by 0. So I find the mean, cast it double so that I don't throw away the decimal parts, and then I get the rounded mean. We have done this a million times. Add 0.5, cast to int. We print to file sum of all the tests, we have that. Number of tests, num tests, we have that. Real average mean, we got that from here. And rounded mean, we got that from this expression here. So we print all that linearly. In your lab 5, you have to do a table. So please learn as you did in lab 4 how to do that table. And you don't have to print. In lab 5, you don't have to print everything. Look at the table, it will tell you what to print. Okay, so then we do the grading. This is very clear to you for quite a while. Rounded mean greater than 0 means A, greater than 80 means B, greater than 70 means C, greater than 60 means D, otherwise means F. And then we print their semester grade. And other data was printed earlier already. And then, as I said before, that'll be like you didn't take any test. And I do believe I did num students plus plus. As soon as I entered the UF loop right here, this will be printed outside the UF loop. But by the time I have done grade determination, which started 13.12, and the else block to that, where I said you didn't take any test, then I'm done and I end the outer while loop here, and then I print to file and console total number of students, and then of course how many people got A, B, C, D, or F. That's the additional task that you will learn how to do that in this document. Always understand you have to close output file, and then you have to close input file, etc. Now this has the same structure that I had in the Boolean table. So like I start with this box here, if not open or else, that means file got open, and then I open the output file, this else block. So this else block has this line keeps going, and you can see that this line keeps going until I have written to the output file and done all the computations until I see that okay, excuse me for a second. I might be missing an else block here which says that couldn't open the output file. Yeah, I think I'm missing something, but nevertheless, up to here is closing block of output file and close output file, but there should be a block here saying output file could not be open. So, and then you have block within a block within a block. You can see, I think my goal was to introduce this, but you'll have to sit down with this document, pore over it, and understand it in more detail. We have tried to explain the structure to you in many different ways, through the PowerPoint pictures, through the Boolean table pictures, through the flowchart, now through the high-level algorithm, and now through the detailed algorithm. But this algorithm is your map for the source code. Once you have done in this detail, developing source code is extremely trivial, and that's our goal, that we do so much work on the details of algorithm that our developing source code becomes a trivial task. Because once you're on the computer and you make mistake, that's actually more frustrating than making mistakes on a piece of paper, which you can always fix. Okay, so this was video 3 of 4, algorithm and flowcharts. For design example 5, data processing using nested loop. And this is Dr. Satish Singhal, PhD, Professor of Computer Science at Communal College, saying goodbye to you from video 3 of 4. And soon I will see you in last video, which is video number 5. Thank you.